In our opinion, the monopoly is the most interesting market structure that you can find in chapter 4. So let's begin with a few concepts and recapping a few things that we learned in the previous video. Let's look at what are the market structure determinants that determine that a firm is indeed a monopolist in this market. The most obvious fact of a monopoly is that it is the only seller in the market that is serving many different buyers. One of the reasons why the monopoly is the only firm might be due to imperfect information, where customers do not know they can actually get the same good at a lower price. It can also be because of zero mobility on the buyer's end. Even if they know that there is something that's cheaper, they cannot act on it. They cannot go to that place which is cheaper, maybe it's too far. Another reason is because of a very highly differentiated good that this monopoly is selling. There's no other competitors, and also because of high barriers to entry. There might be certain things that are disallowing other companies from coming in to compete with the monopoly. So these four factors actually gives the monopoly what we call market power. So it's got the highest market power among all the market structures, which gives it the ability to set the price. And we've also learned in the previous video that the monopoly is the most allocatively inefficient market structure. And this is because it has got the highest amount of deadweight loss. We discussed this in the previous video that the deadweight loss is a loss in utility on the society's end. As long as the equilibrium market price of a good is not determined by the intersection of demand and supply, you are going to have deadweight loss. As seen in this, the monopoly price is PM, and over here the blue portion is the producer surplus, and the green portion over here is consumer surplus, and you have this amount of deadweight loss that is shown in red. Society is losing out because of the monopoly's gain of charging a higher price to the consumers. Therefore, the consumers lose, and that is what we call the deadweight loss. So, another thing that the monopoly is able to do because of its market power is, of course, to practice price discrimination. So the definition of price discrimination is as follows. Okay, a monopoly is exercising its market power so that it can sell the same good at different prices to different consumers. I'm going to use 3 examples to illustrate this. Now, the first example could be students or elderly people getting lower bus fares when they take public transport. So the rest of the people are going to be paying higher fares. So that is an example of price discrimination. A second example could be student card discounts. And another example would be first class passengers that have to pay more for airfare. Well, if you think about it, traveling from one place to another is still the same good. And I don't think it's that expensive to actually serve first class. So it is essentially charging them much more for that same good. But it is not all the time that the monopolist can price discriminate. So let's take a look at the conditions that are necessary for the monopoly to do just that. Now that condition is called the no arbitrage condition. So what is arbitrage? It actually refers to people taking advantage of price differentials. The price differentials here means that the same good is selling at different prices in different places. To use a real life example, let's say that there is a camera, a digital camera that is selling at $500 in stores. And then you came along and you are the only person in your neighborhood that knows where to buy one elsewhere for only $300. So you're really enterprising, right? You buy some of these cameras and you stand outside the stores and you sell these cameras for $400. Well, that means that you'll be making a profit of $100 for every camera that you sell to a passerby. So that's an arbitrage opportunity right there, and monopolists can't have this in the society. If not, they won't be able to do price discrimination. So we don't want to have arbitrage so that monopolies can charge different prices without you knowing it. So there are typically 3 things that must happen for there to be no arbitrage opportunities in this market. Now, the first thing that needs to happen is that the buyers cannot be able to resell any goods and services that they buy. One very good example of this would be haircut services. So if I'm a student and I'm going to get maybe a good discount for haircut, I can't pay for the haircut and then let you, somebody that doesn't get the discount, have the haircut, right? So it's untransferable. The second condition for no arbitrage could be maybe high transaction cost. So think about it. If it's going to cost you $200 to import this camera, do you think you can be making any arbitrage profits out of this? Now you have to add $200 to the price at which you bought the camera, and that makes your total cost $500. So do you think you'll be able to sell lower than $500? No. People would rather buy from the stores than buy from you if you were just to charge $1 more expensive. The next condition is that there must be zero information. And there will be zero information when the markets are properly segmented because the agents within those markets can't talk to each other. If you didn't know where to get that $300 camera from, do you think you would even think of having this arbitrage profits? You wouldn't even know where to get a camera that's $300. So those are the conditions for a no arbitrage market. So there are actually three different types of price discrimination. We call it the three different degrees, and you will only be tested one of them in your Intro to Econ series. So just let me briefly go through the first two. The first one will be called first degree price discrimination. So this is not important for you, so I'm just going to briefly go through it. First degree price discrimination occurs when the monopolist can sell to every single consumer at his or her reservation price. The reservation price refers to the maximum willingness of each consumer to pay. It is very obvious that monopolistic firms like these need to know all the reservation prices of all the different buyers, and they also need to be able to differentiate all the buyers so that they can charge them at their respective reservation prices. First degree price discrimination is also the most severe form of price discrimination because the monopolists would end up charging the consumers the most. However, as severe first degree price discrimination can be, it is actually allocatively efficient. The monopolist would some way, somehow be able to capture all the consumer surplus such that there is no deadweight loss in the market. More of these to come in microeconomics, managerial economics, as well as industrial economics. So maybe it'd be good if you were to share this with your friends. Second degree price discrimination, which is also not tested in the Intro to Econs, occurs when the monopolist sets the price depending on the quantity that you demand. Again, this will be featured more in microecons, managerial econs, as well as industrial econs. So if you really want to know more about this, maybe you can take those units next year. The last kind of price discrimination is third degree price discrimination, which is very, very important for you because this is tested in your syllabus. So third degree price discrimination refers to the monopolist selling that same good at different prices to different customer segments. So for example, segments can be things like sex, age, as well as location. And obviously, the monopolist must be able to know the demand equation for each segment. And to make things a little bit simpler, for Intro to Econs, we will only be talking two different segments of customers. And another point about third degree price discrimination that you should know is that it is allocatively inefficient. There is bound to be some deadweight loss, and there will always be deadweight loss when the price doesn't equals to the marginal cost at the equilibrium quantity produced and sold. Just remember that by the general rule of thumb, whenever the price is equal to the marginal cost, you have an efficient market. Let me use a simple demand and supply graph to show you what I mean. At some point, you will learn that the supply curve is actually the marginal cost curve. And if the price was determined by the intersection between the demand and supply, you would have the consumer surplus in that green box and the producer surplus being that blue box. So as you can see, there's no deadweight loss in this case when P equals to MC. Now that we've got all the theoretical stuff done, let's go through the graphical approach on how to analyze a monopolist. How do we analyze monopolist behavior using a set of tools? So you're going to need a few things for the initial setup. The first two things that you're going to need is number one, the demand curve, and number two, a marginal revenue curve. What you need to understand is that the marginal revenue curve is actually derived from the demand curve itself. So I'm going to need to use some algebra to explain why this is the case. So let's imagine that we have a demand function that goes P equals to A minus B times X. So A and B are actually constants, and X is a variable, obviously, it's a quantity produced. And A is also known as the maximum willingness to pay by the consumers. And there's a negative sign in front of B because of the law of demand. As you produce more, the price should drop. So how do we find out what is the marginal revenue curve? So to find marginal revenue, what you need obviously is total revenue first, right? So total revenue is going to be price multiplied by quantity. So you're going to substitute the whole of the demand function into that, and you're going to get the following figures over here. And to get marginal, what you need to do is to differentiate the total revenue with respect to X, and that will give you an MR. And then you're going to get this. Notice that in this equation, the coefficient of X is going to be 2b. In the demand curve, the coefficient of X is going to be simply b. Since the coefficient of X refers to the slope of the curves, what you'll notice is that the MR curve is actually 2 times steeper than the demand curve. And both of the curves have the value A when the value of X is 0. That leads me to two very simple conclusions. Number one, the MR curve is going to be 2 times steeper than the demand curve. And secondly, both curves are going to start at the same point, which is point A. So here's a simple demand curve with the vertical intercept A. So a marginal revenue curve that is 2 times steeper than demand curve will simply look like this. And remember that it has to start at the same point as the demand curve, which is point A. The next thing that you're going to need is a marginal cost curve. Now, your marginal cost curve simply is the supply curve for the monopoly. And the question you should be asking yourself is, why is the MC curve the supply curve as well? Well, that is because of the profit maximization rule. And it says that the firm is going to supply where marginal revenue equals to marginal cost. So marginal revenue equals to marginal cost simply helps the firm to determine the amount of X being produced and sold. As you recall in chapter 3, your marginal cost curve is upward sloping, and it doesn't always have to be a curve, it can be a straight line as well to make things easier for you. So this is the point where marginal revenue equals to marginal cost. So you know that the firm is going to be producing X naught amount to maximize their profit, and we call this the profit maximizing quantity. How much they can charge? You basically have to refer to the demand curve, and they're going to charge at P naught. And P naught is the profit maximizing price. Notice that this is the deadweight loss over here. And you are sometimes going to need your average cost curve. And the purpose of having the average cost curve is to simply find out what is the size of the profits the monopoly is making. Let's say we have an AC curve that looks like this. We need to find out what is the average cost of producing X naught amount of goods. So we actually go up and see where X naught touches the average cost curve, and that is going to be the average cost per unit produced. Since the price, which is also known as our average revenue if you think about it, is higher than the average cost per unit, that means that the green portion highlighted over here is the total amount of profits that the monopoly is making for producing X naught amount of goods and selling it at P naught. What if for some reason fixed costs were to decrease and I have an average cost curve that looks like this? So again, I'm going to shift up to the average cost curve, find out what is the average cost of producing X naught amount. Notice that this red portion is the new total profits that is being made by the monopolist. What if the average cost curve looks like this? What is the new amount of profits earned? Well, you'll notice that the average cost is also equal to the price. Therefore, you can see that there is actually no profits being made by the monopolist. And if the AC curve were to shift up to this level, what you'll see is that the average cost is now over here, and the average cost is now higher than the price. So when the cost is higher than revenue, you get the purple portion, which represents the losses that the monopolist is making. So that is how we identify profits and losses on the graph. Now, just a little bit of extra material. Did you know that the price elasticity of demand is actually different along the demand curve? What I'm saying is that if you look at this demand curve over here, there's going to be one point where the price elasticity of demand is going to be equals to 1, or what we call unity. And you have the portion on the left, which is elastic. And then you're going to have the portion on the right, which is inelastic. I think many of you out there will be asking me to prove it, so here we go. So you remember this equation, right? Please say yes. So that's one thing you need to know. And the second thing is that the slope of the demand curve is the change in price over the change in X. But the demand curve is a straight line. Therefore, the gradient is the same throughout. Therefore, dp over dx is going to be no change as x increases. So dx over dp is also going to be no change, so this over here will not change. This, however, is actually the gradient of a ray from the origin to the demand curve. Let me show you what I mean. If you look at this point, I want to find p over x. I just have to draw a ray over it and find the gradient of this ray. So I'm going to take p divided by x. So this is steep, right? It means the value is going to be quite high, the value of P over X. And take another point, which is over here, and I'm going to find this P and divide it by a bigger X. I'm going to get a flatter gradient, which is a smaller number. So therefore, as X increases, P over X is going to decrease. Therefore, based on the equation of price elasticity of demand, the price elasticity is going to decrease as the quantity of X increases. And there you have it. I've proven my case. The elasticity along the demand curve is different throughout. Well, here's another interesting thing that you might want to know. This quantity of X, where the price elasticity of demand is unity, is also where the marginal revenue curve will intersect. So most of you out there might be saying, I don't believe this bullshit. Prove it. So for me to prove it, I need to do some math. Total revenue equals to price multiplied by quantity. And the reason price is a function of X is because we took the price from the demand equation. I'm going to differentiate total revenue with respect to X to get marginal revenue. I'm going to get the first differential of the demand equation multiplied by X plus the demand function again. And this is because of the product rule. Simple differentiation. Now I'm going to factorize the demand function out of the equation. I'm going to get this. So I need to divide X by the demand function, and the demand function is going to be left with 1. And what you notice is that this figures over here is actually the inverse of the price elasticity of demand, which is always negative, right? So the marginal revenue can also be calculated by the price multiplied by bracket 1 minus 1 over the price elasticity of demand. Now this is a very important equation for you to learn. We're actually going to be using it in the next few videos as well. So if the price elasticity of demand is going to be 1, then the marginal revenue can be calculated as follows. 1 minus 1 over 1 is obviously going to be 0, right? So marginal revenue is 0. There you have it. I've proven it. This is the point where marginal revenue equals to 0, when the price elasticity of demand is unity. See? And if the price elasticity is more than 1, maybe it's equals to 2, then my marginal revenue can be calculated as such. I'm going to get a marginal revenue that is positive. So you see, marginal revenue is positive when the demand is elastic. See? Proven. Next, what if the price elasticity of demand is less than 1? It is inelastic, maybe 0.5. So I'm going to calculate my marginal revenue again. And what you'll notice is that I'm going to get a negative P. So that's a negative number, right? So that is my last proof that when the elasticity is inelastic, you're going to get negative marginal revenue. Simple. So if I draw a graph with, say, maybe the total revenue on the vertical axis, and on the horizontal axis, as I move towards the right, my elasticity is decreasing. What you notice is that the total revenue curve will look like this. And it's going to peak at where my price elasticity of demand is going to be equals to 1. Okay, and it is actually decreasing when the demand is inelastic, and there's a reason for this. Because to sell one more unit of X, the firm must reduce the price by a lot. Okay, and the reason is because when the demand is inelastic, the consumers are very price insensitive. You need to reduce it by a lot more so that they will buy an additional unit. So not really worth it, right? So on the left hand side, that's where the demand is elastic. To sell one more unit of X, you just have to decrease the price by a little bit, you'll be able to sell one more unit. And that is because they are price sensitive. Okay, we're done with that. Trust me, this is some advanced stuff. It'd be really great if you could understand this. Okay, so now we'll be moving on to something else. What if your monopolist has to serve two groups of consumers who have got very different demand equations? Let's just say that these two groups of demands can be either inelastic, elastic, or perfectly elastic demands. What the monopolist would like to do is to actually sell to the inelastic demand first. Okay, so they move on to the elastic demand and then they serve the perfectly elastic demand the last. So you might be wondering, why is this the case? Well, that's because for the first few units that the monopolist is going to produce and sell, the monopolist can actually sell it at a higher price because there is a low quantity in the market. And also, at a low quantity produced, there is a lower MC. Well, that just means that it's more profits for the monopolist, right? So it makes more sense to serve the inelastic demand first. So when a monopolist serves two different types of demand, the demand curve that he is facing is actually a kink demand curve. So a kink demand curve is basically a straight curve that bends in another direction after a certain quantity. So you might be asking, why don't we just take the average elasticities of the two demand curves, all right, and then have it as one demand curve. So you can't do this because the monopolist can actually clearly segment the two markets. So when they can clearly segment between the two markets, it actually makes sense to serve certain customers first because of the reason that we just discussed earlier. Okay. So the thing is that you might have two different profit maximization points when there's a king demand curve. And in order for this to be clear to you, we're gonna have to do some drawings to show you graphically how this can happen. I'm now going to combine two demand curves together. So I have either elastic or inelastic demand on the left hand side, and on the right hand side I'm going to draw a perfectly elastic demand curve, which is simply a horizontal line across. So what's going to happen when I add these two demand curves together? You have to understand that the people that have perfectly elastic demand are only going to be willing to pay this price, no matter what the quantity in the market is. So this is what the demand curve is going to look like. It's going to kink at where the maximum willingness to pay occurs for the perfectly elastic people. So as you can see, this is the combination of the two different demand curves. And the next question you should be asking yourself is, so how do I draw my marginal revenue curve? The first portion of the marginal revenue curve will be pretty much the same. So it's just a MR curve that is 2 times steeper than the demand curve. And then the marginal revenue curve is going to be a horizontal line that is the same as the demand curve. And as always, I will prove why there is a flat marginal revenue curve. So I hope you recall that this is the formula to find marginal revenue. And since the demand is perfectly elastic, that means the price elasticity is infinity. So I'm going to put infinity into the equation, and you notice that 1 over infinity tends to become 0. The next simple steps will tell you that the marginal revenue equals P, and P over here is simply the market paying price. Okay, so look at the perfectly elastic demand. If this is P naught, then the marginal revenue will be constant at P naught after the amount of X naught. Okay, because this is satisfying the perfectly elastic demand. And your price is also known as your average revenue. Think about it. The average revenue is a fixed amount that you earn, so is the price, right? Only the marginal revenue changes as you produce more. The next thing I'm going to do is to draw my marginal cost curve, and I'm just going to make it cut through the marginal revenue curve at 2 points. Over here, point A, and over here, point B. So these 2 points have got MR equals to MC. Now you're going to have 2 sets of equilibrium quantities and prices. Okay, one at point A and the other one at point B. So from X1 to X2 is actually the portion that the monopolist will be supplying the perfectly elastic demand. And 0 to X1 is simply where the monopolist is supplying to the either elastic or inelastic demand. See, it's that simple. Let's look at the second case. What if this time the monopolist has to serve firstly an inelastic demand and secondly an elastic demand? So how do you combine these two demand curves together? Well, it's pretty much the same way like how you did for the previous 2 sets of demand. You're going to have to mark out what is the maximum willingness to pay of the second market is going to be. And we know that is this at this point. Okay, so this is the maximum willingness to pay. And when you draw the kink is going to happen on the red dotted line. And we have already established that the marginal revenue curve is going to simply look like this. What do you think the marginal revenue curve would look like for the elastic portion? Do you think it's this? Some of you might say yes, but actually the answer is no. The marginal revenue curve must begin at the same point as the demand curve, which is over here. So this is where you measure a line that is 2 times steeper and then you draw it as your marginal revenue curve. So that is how you draw the MR curve. I'm just going to add in my MC curve so that it cuts through the marginal revenue at 2 points. And then again, I'm going to have 2 sets, okay, 2 sets of equilibrium quantities and price. So I've got X1, P1, and I've got X2, and P2. And to go through one more time, from X1 to X2 is the amount that the monopolist is going to use to supply the elastic demand. From 0 to X1 is the amount that the monopolist is going to use to supply to the inelastic demand. Question: if the monopolist cannot price discriminate for some reason, which market do you think it should serve? Well, of course, it should serve the market that gives it the most profit, right? And we've just established that it's usually the inelastic market, which is the first market segment that we see over here. And that means in the first case, the monopolist will produce up to X1 and sell it to the first market at the price of P1. And the same thing for the second market, they're going to be producing to amount of X1 and selling it at P1. And just a quick recap to the reason why: there is going to be a higher price and a lower MC, therefore there's going to be higher profits for the monopolist. Very obvious, okay? But now let's move on to the more interesting question. What if the monopolist can practice some price discrimination? Third degree price discrimination to be specific. So the question is, should we sell to both markets or just the first market? You will understand the reason why we ask this question when we go through the concept of the area of gain and the area of loss. So how does the monopolist, when practicing third degree price discrimination, decide on whether to serve one market or two? Now, the concept that they use is the concept of marginal profits. So what is marginal profits? Marginal profit is basically the additional profit that the monopolist can earn from producing and selling an additional unit of X. It's just like marginal cost, just like marginal revenue. But this time we're talking about the additional profit that is being added. Your marginal profit can either be positive or negative. And if your marginal profit is going to be positive, it means that for every X that you produce and sell, you're going to get more profits, right? So you should proceed to produce. If it's negative, then obviously you stop, because by producing more and selling more, it's eating into your profit. So you don't do that, right? So since profit is total revenue minus total cost, marginal profit would then simply be your marginal revenue minus your marginal cost. Makes a lot of sense, right? But we're not using math, we're using graphs. So how can we use the curves to identify which is bigger? So you can either have the marginal revenue curve being on top of the marginal cost curve, or you can have another case where your marginal cost curve is actually above your marginal revenue curve. In the first scenario, okay, the area between those two curves is what we call the area of gain. And when the MC curve is higher than the MR curve, the area in between is called the area of loss. You might be able to get what I'm trying to drive at. Okay, so to decide on whether it's one market or two markets, when the area of gain is bigger than the area of loss, then there is positive marginal profits, right? So in this case, you should continue to serve two markets, produce more and serve the second market. However, if your loss area is going to be larger than your gain area, then you're going to have negative marginal profits, which means you should stop proceeding. You should just serve the first market and be happy with the profits that you get there. So this is how the monopolist decides on whether it's going to be one market or two markets. And of course, we're going to need to show you on the graph exactly what we mean. But the very fact that you've got the theory in your mind actually makes this much easier for us to go through. Okay, I'm going to be using the example where the monopolist is serving a elastic demand as well as a perfectly elastic demand. So that's the demand curve and the marginal revenue curve, and my marginal cost curve is in red. So these are the two profit maximizing points that the monopolist can choose. So it's either X1, P1 or X2 and P2. So the question is this: should the monopoly sell X1 at P1 to the elastic market and at the same time sell X2 minus X1 at the price of P2 to the perfectly elastic market? Or should the monopoly just sell X1 at the price of P1 to the elastic market? So the choice between option A and option B depends on whether there is positive marginal profits for producing beyond X1 and selling it to the perfectly elastic market. So let's begin our analysis for the quantity between X1 and X2. So this triangle over here is formed with the marginal cost curve being on top of the marginal revenue curve. Therefore, I'm going to highlight that in red and I'm going to call that the area of loss. Moving on to the quantities between x2 and x0, this triangle here is formed with the marginal revenue curve on top of the marginal cost curve. Therefore, this green triangle is called the area of gain. So now we move on to see how the monopolist is going to choose between A and B. Now, if the area of gain is more than the area of loss, then we know that the marginal profits is going to be positive. Therefore, the monopolist should choose A because he is producing beyond x1, which is going to give him more profits because marginal profit is positive. Now, if the area of loss is larger than the area of gain, then clearly the marginal profit is negative. Therefore, the monopolist should choose B because producing beyond x1 is going to give him further losses. You should know that this graph is not drawn to scale because there isn't any numerical figures that we can refer to. So since it's not drawn to scale, we can't tell which area is bigger, which area is smaller. Therefore, you're going to have to present your answer during the exams in this particular format that is circled in green. Okay, so that's going to be the answer for the exams, and the simple reason is, as I said, these graphs are not drawn to scale. So that was the end of the graphical approach. Let's talk about the mathematical approach. Now, this is not very important. The probability of mathematical problems coming out in the Intro to Econs exams is actually pretty low, but it'd be really good for you to know this in case it comes out. So this is a demand curve over here, and let's just say that there is a total cost function that looks like this: C times x to the power of 2. So A, B, C are constants, and of course x is a variable because quantity is determined by the monopolist. So a typical question that you might encounter is to find the equilibrium quantities of x and the equilibrium price set by the monopolist. So what you need to do is to identify what is the profit function, which is simply the price multiplied by the total quantity minus the total cost. So the price will be replaced by the demand function, okay, and you've got this. So it's basically total revenue minus total cost. What you have to do next is to find the first order condition of the profit function with respect to x because you want to maximize the profit. So you differentiate the profit with respect to x, and then you're going to get this. Remember to equate that to 0, and what you notice is that you have MR minus MC. So that is actually the profit maximization rule that we've been talking about the whole time. And I've just realized that I forgot to put an X there. I was just testing you, okay? So that's the correct equation. So what I'm going to do next is to actually solve for X, okay? And this is the equilibrium quantity that the monopolist is going to produce. I'm just going to denote it as XM, okay, to show that this is the monopolist quantity. So what I'm going to do next is I'm going to have to find the price, right? So I take the demand function and substitute the quantity inside it, and basically I'm just going to skip the steps here, and what I should get is this algebraic expression over here. Okay, so that's the monopoly price. So now that I've got this and this, I can actually find what are the profits of the monopoly in terms of the constants using the quantity of X produced. Okay, we're almost at the end. Just one last point before we finish up this video. Now, when you talk about MR equals to MC, you need to make sure that both the marginal revenue function and the marginal cost function are functions of the same thing. It is either quantity or price. But for the purpose of Intro to Econs, most of the time, you just be using quantity, okay? So forget about the price. Alright, that brings me to the end of this video. It's been a bit lengthy. Well, maybe it's because it's our favorite chapter. Anyways, I would like to thank you for studying with Quickienomics. We'll see you in the next video on perfect competition.